graphs. So section 6.2 is all about graphing sec x, y equals cosec x, and y equals cot x. So I'm going to go through the graphs of all those three functions so you know exactly how to do it. So sec x, to sketch sec x, you're going to sketch cos x to begin with. Okay, so first of all, sketch y equals cos x. So that's what we'll do. Do it lightly. So your cos x, let's just draw it like this. Okay, and then just learn the following technique. So let's just generate a few values. So let's see what happens for those key values for when x is equal to 0, x is equal to 180 and minus 180, and x is equal to 360. So when x is equal to 0 and 360, you are going to have sec 0, let's just do that, which is the same as 1 over cos 0. Now cos 0 clearly gives me 1, so that's going to give you 1. So at that point, at those two values, you are going to be hitting those. If you were to draw it further, those points will belong to our y equals sec x. Then let's look at those points over here. So when x is equal to plus or minus 180 degrees, sec is going to be plus or minus 180 degrees is the same. So that's 1 over minus, let's just put cos first of all, plus or minus 180 degrees, which gives me 1 over minus 1, which is minus 1. So again, these points here will belong to y equals sec x. Okay, now what happens when cos is equal to 0? So when cos is equal to 0, then cos x is equal to 0, then x is going to be equal to plus or minus 90, plus or minus 270, etc. So what will happen to our cosec? You'll have y equal to, sec x, which is 1 over cos x. So you will be getting 1 over 0. That's impossible. So undefined. Which means x cannot be equal to plus or minus 90, plus or minus 270. These are asymptotes. So let's sketch them. So the asymptotes are going to be whenever the cos x hit 0. So when it had its roots. So sec will have asymptotes there. 90 minus 90, 270, and the other one is minus 270. Okay, so far what do we have? We've got this point, this point, this point, this point, and we know that it's undefined for 90. So in order to be convinced of the next stage, what will happen is we're going to investigate the values between 0 and 90 and see what happens. So I'm just going to go it really, really briefly. I'm going to test a value that is really, really close to 0 and see what I get. And then I'll test a value that will be very, very close to 90 and see what I get. So let's have x tends to 0. So it's close to 0. You can write it as 0 plus if you like, or minus if it's on the other side. So what you will have is y equals to sec of that 0 plus that value. now, which is 1 over cos of 0 plus. Now, if you look at the cos graph, at the value close to 0, it's going to be almost 1, but not quite. So it could be 1 over, let's say 0.99, something close to 1. Now, if you divide 1 by something that's close, well, smaller than 1, you'll get a value just greater than 1, so 1 point something. Okay, so it's above 1. So maybe somewhere here. And the same thing will happen on the other side. Now, if you explore the value close to 90, but not quite 90, so on this side, you'll be dividing 1 over cos of something that's close to 90. I don't know, let's say 89. You can test it on the calculator. Point something. So it's 1 over. Now look at this value here. This is going to be really tiny. So it's something like 0.001, for example. So it's 1 divided into tiny bits. You will have a really big answer here. Now positive, if you divide it by positive value, so it's somewhere here. So that's what it looks like. So what happens here, for very small values of x, your cos is close to 1, and you'll be dividing 1 by something that's close to 1, but just a little bit less than 1. So the answer will go above 1. Now, if you divide by something that's close to 0, then you'll get a really big value. Now, the same thing will happen for this side, and the same will happen here. So the asymptotes act like those barriers, so the graph tends to the asymptotes, tries to get really close, never quite succeeding. Now, if you deal on this side, the opposite values will take place, so everything happens in negative values, but the shape will be very similar. Now, what you could do if you're not sure, because although it's normally students find it easy to remember the sketch, you can just test a few values for yourself. So this is the technique that we use for sketching sec x. Okay, so first you sketch the y equals cos x, then you identify the values when cos x is maximum and minimum, then asymptotes, and then number 4, sketch. Okay, so let's actually do this one quick, and we'll put all the properties together in one go. So if I ask you to sketch sec x, you're going to sketch cos really quickly. So let's say, let's do a tiny one. Identify the key points. So here that happens at -1, and that's at -1. This is 360, -360. I'll just mark 180 as well, and -180. Draw the asymptotes. So this is where the cos graph hits 0. And then you just do the dots, so the maxima will be the same, they stay in the same position, and there you go. Okay, once you've sketched it, you can actually identify the properties. So the domain, you see the domain is x's belong to all real values, but x cannot be equal for those values of x when we were dealing with asymptotes. So x is not equal to plus or minus 90 and plus or minus 270. Let's just put the asymptotes. So x is equal to plus or minus 90 and plus or minus 270 if you go from minus 360 to 360. Now what's the range? So what values of y do you obtain? So if you look at this, if you were to go along the y-axis, you're going to be hitting the black curve all the time. And the last time here is at minus 1, and then nothing up until 1, and then again you'll be hitting the curve. So y is going to be belonging to, oh, let's put it like this, less than or equal to minus 1, or y is greater or equal to 1. You can't put these two together because they're two separate regions. Okay, so let's do the same for cosec x. So this one should be a lot quicker. I'll just do the one up to 360 from, let's do it from 90. Okay, so, let's do from 100, minus 180. So you're going to 180, 360, let's do more because I've sketched more. Okay, so asymptotes, I'll just put all the values first. So you've got 1 here, minus 1, this is 360 and 180, that will do. Okay, asymptotes are over here. And then we're going to have a graph like this, a graph like this. There you go. Okay, so here's the graph. So you've got these values identified at the maxima of the sine graph and the minima of the sine graph. Asymptotes where sine graph crosses the x-axis, and then you just do those I don't know, U shapes and upside down U shapes, if you like. So what's the domain? Well, the domain is all real values apart from when we had the asymptotes. So x is all real values, but x is not equal to plus or minus 180 degrees and 360 degrees. So multiples of 180, if you like. Asymptotes are those 180 and minus 180 and 360 and minus 360. The range, again, you could see that you'll be cutting the graph apart from that band in the between 1 and minus 1. So the range, you can have any value for y less than or equal to minus 1, or y greater or equal to 1. Okay, and finally we've got tan. To sketch tan x, we're going to use both definitions. There you go. So, sine. Okay, the last graph we're going to sketch is y equals cot x. This is quite helpful, but this is really, really helpful as well. So both definitions will be needed to realize the shape of cot x. So the first thing, I'm just going to sketch my tan first. Because like I said, it will be very, very helpful to have it drawn. So let's sketch tan. Remember, tan has the asymptotes so at 90 and 270. So plus or minus 90. Then it goes through 180 and then another asymptote at 270. And then you can carry on. It repeats itself every 180 degrees. So let's pop it down. That was at, this one was 90, this one is at 180, and this one is 360, and that one was 90, that's 270. Okay, so this idea of looking at where the graph crosses the x-axis being the asymptote of your reciprocal of a tan graph gives us x equals 0, x equals 180 and minus 180, and 360 and minus 360. So these are the asymptotes. X equals 0 plus or minus 180. It's a repetition of these, plus or minus 360. By the way, for sine, we had 0 as well, was the asymptote today, not included on cosec. Which is, you also need to have x is equal to 0. Here, x cannot be equal to 0. That's important. Forgot to spot that one. Okay, so, and also you could have actually established that by looking at this definition, because the asymptotes will occur when you have a 0 in the denominator. So when sine x is equal to 0, so that happens for those values 0 plus or minus 180, plus or minus 360. Now, where will this graph, because it will, cross the x-axis? So the intersections with the x-axis. Okay, so because if you look at this definition and you try to make that equal to 0, you might think, well, that will never be equal to 0 because 1 can't be equal to 0, and you know, it just won't work. But if you use this definition, you can say, so that will happen when, so cot x is equal to 0 when cos x over sine x is equal to 0. So that way you could see that this happens when cos x is equal to 0. So what I'm talking about, cos x is equal to 0, if I were to draw a cos graph, it would happen at 90. And then I just sketch it really lightly to remind you there. It will look like this. So it's 90. You can just solve it using a calculator. And plus or minus 270. And then you've got 450. But let's just stay at those values. Okay, so that is going to be where my cot will cross the x-axis. Now, what about the shape? So we'll do that definition, use that definition for exploring the values. So what happens? So first of all, you could see that this is going to be an asymptote. So let's see when x tends to be very, very small but close to 0. So you could sub x equals to 0.01 into the calculator, or even 0.1 into the calculator. And what are you going to get? Y is going to be equal to 1 over tan of that value that's really, really close to 0. You can pop it into the calculator, and actually you should see that you are dividing over here by something really, really tiny. Okay, so this is going to be something very, very big. Okay, so your asymptote will be over here. Now, what did we say? We said that it will cross the x-axis at 90. So this is the shape you are going to be getting. Okay, now what happens to a value close to the other asymptote, so 180? So when x tends to 180 from left, so for example, x is equal to 179.9, something like this, then for your cot, you will have tan of that 179.79, etc. So this is going to give you very big answer as well. Okay, so if you put that into the calculator, you could see that tan is very, very tiny for those values close to 180. So cot must be very, very big. But it's going to be negative because cot is negative there. Should have put that minus. pop it on the calculator and see. And the same will happen there. And then there. And then this repeats itself every 180. So let's have a look at the features. We've got to look at the domain. So the domain, if you look at this, is my y-axis. This is the x-axis. The domain is all possible values belonging to the real set numbers, set of real numbers, apart from plus or minus 180 and the multiples, so plus or minus 360. I've already included the asymptotes, so the range. So with the range, you've got, look at this. So this actually, the same happens with tan. The range is, you don't really have any restrictions. You will always get the y value, no matter what x is, as long as it's within the domain. So y belongs to the set of real values. I also say that it repeats itself every 180 degrees. And with something we haven't mentioned with these here will repeat every 360 degrees, just like sine and cos. Should be y equals sine x, cos equals, and y equals cos x. Perfect. So you should be able to sketch transformed graphs of cosec function as well. So this is example 4. I have skipped example 3 because it just asks you to sketch sec theta. I went through all the other graphs to help you anyway, so you don't need to have the repetition of the previous graphs. So all you need to do is sketch, well, you've got a choice. You can sketch your cosec x and then stretch it by 4, which probably I will go for in this instance. You could have sketched sine x and then stretched it by 4 and then draw cosec from that, but I will just go for sketching cosec. So I'm going to sketch cosec, but I'm not going to indicate scale along the y-axis because this is the stretch with a factor of 4 along the y-axis. So just quickly remind myself, we're going to draw the sine graph. Okay, I've gone up to 2 pi, so let me just go because it's asked you to go from minus pi up to pi. I have 2 pi for good measure. Okay, so remember the asymptotes are over here. I said I won't put any scale on the y-axis. I'll just have to amend it in a minute because it will be stretched. And the graph is going to be like this. So this is your cosec. Let's just add this one to the picture. Okay, now this is stretched along the y-axis with a factor of 4. So that means all y values need to be times by 4, which gives you, you can either sketch it again, or you could just say that this is 4 and this is minus 4, and you're done. So this is y is equal to 4 cosec x. There you go. And then it says on the same graph, let's sketch y equals x. So you need to be very careful because the scale here is a bit skewed. It's not a perfect square scale. Pi is about 3.14. So if you could see there, for if I'm sketching y equals x, when x is equal to 3.14, y is going to be equal to 3.14, so somewhere here. So pi and pi will go somewhere here. So this will tell me that the line will look like this. Okay, so how many solutions does the equation 4 cosec x equals x will have? So you can see here there is no points of intersection of y equals 4 cosec x and y equals x, so no solutions. Okay, we've got one more example before exercise 6b. So example 5, it asks us to sketch between 0 and 360 the graph of 1 plus sec 2 theta. So what I'm going to do, I'm going to sketch sec 2 theta, and then I'm going to deal with adding 1 to the result. So let's have a look at sec 2 theta. I'm just going to have a quick reminder on the side. My sec theta, what would it look like? So you would have to draw cos first. These are the asymptotes at 90, minus 90, and 270. And then you have the graph that looks like this. We're meant to draw it from 0 to 360. Now that happens at 1 and then minus 1. Now, if it's 2 theta, what this represents is squash. So we're halving everything, so squashing it by 2, or the scale factor over half, if you like. So we're going to halve all of this graph, squash it, so you get twice as many asymptotes and twice as much graph. So you need to draw it twice. So this is my first asymptote. This is 270. So this one was... Let us not draw any numbers because they will be squashed. Just go a little bit more. That should be enough because we'll have twice as many. So this will become the last asymptote. This one is first asymptote. That was at 90 over here. Now it's going to be at 45. This one was at 270. Now it's going to be half that, so it's going to be 135. Okay, now the next asymptote would have happened at 450. So it is going to be a 225. Okay, and the next asymptote, it would have gone here before being half from 270. It would be 360 further along. So it's going to be 7. Okay, got interrupted several times. Anyway, so the next asymptote is going to be 315. Okay. Right. So if you could see that these points here, that was happening at 1. So this is 1. This one will have the upside down U at -1 here. The y values are not affected by the scaling along the x-axis, so they will remain the y values as they are. There you go. So if you want to identify these points, obviously they were before over here at 180. So that would be 90. Okay, because actually it's a good job I've done it, because I would have had part of the graph missing, because I need to have this one here as well. There you go, because half, yeah, there should be twice as many. Okay, now for the final part we need to shift everything up by 1 unit. Okay, so it's a bit awkward one to draw, so what I suggest you do, if you want to start from scratch, don't draw the horizontal axis because everything is going to be shifted. I'm just going to pretend this axis here, let's just make it a bit lower there. So I'm going to imagine shifting everything up 1 unit. So what you can do is part of a sketch before you draw it properly. What effectively will happen, these will go all the way up there, so you will have your new position of the x-axis will be there. You've shifted everything. It will help you possibly with sketching it again. Maybe you'll find it helpful. So I need to draw the same thing here. So these points over here, the asymptotes will stay as they are. So just do the lower bits first, they are easier anyway. I'll put all the numbers afterwards. Again, this one here, you can see effectively you will have, if you imagine the x-axis is here, so it's 1, 2. So this one here, just mark those points. That one is not needed. There you go. It's a bit strange. Okay, so this becomes shifted up to 2. This one is up to 0. That remains at 45, 90, 135, 180, etc., etc. So 225, 270, 315 at the end, and 360. So this point here is 362, for example. There you go. So you can go on to exercise 6b.